In our last lesson, we talked a lot about factoring. Factoring is very useful for solving equations. It is also very useful for simplifying rational expressions and reducing fractions. And that's what we're going to spend a little bit of time on today. We're going to talk about reducing fractions, especially algebraic fractions, okay, in which you're going to have to make use of, hopefully, some tools that you learned about factoring. So let's get started. First, rational expressions are fractions of those forms. Hopefully you can see those. Some of them are a little small, but those are all fractions. 3x over x minus 1, 5x cubed over 3x minus 7, 8 over x squared minus 4x minus 9. Those are all rational expressions. Now, rational numbers, as you recall, are numbers that can be written as fractions. So in algebra, we call rational expressions fractional rational expressions where they have variables, exponents, and numbers. Okay, the first thing we want to talk about today is the domain is a set of all possible x values. Pardon my misspelling up there. Notice in the first one above, the domain would be all real numbers except for 1. So the first one here, pardon me, what can x be? What numbers can x be? X here can be anything except for 1. Because you can get all kinds of ugly fractions and weird decimals and whatnot. But if x is 1, you have division by 0, and you can't divide by 0. It has no answer, okay? You could go to this one. This one would be a little trickier. I think this would be 2 1/3, okay? Because if you take 2 1/3 times 3, you're taking 7/3 times 3. You end up with 7 minus 7, which would be 0 on the bottom again, okay? So the domain is all the possible x values, all right? So how about down here? Can we find some domains, okay? Find the domain for 3x squared minus x minus 7. Basically, if there's no fraction, you don't have to worry about division by 0. If there's no square roots, you don't have to worry about taking the square roots of negatives, okay? So 3x squared minus x minus 7, no fractions, no roots. There's never going to be anything illegal. X can be anything. So all real numbers for this one. Now, fraction. We got a problem. Just like this one where x could not be 1, here can be any real number except 5. And just write that out. Any real number except 5. That's your answer. What about this one? All right, let's talk about this one. This is 4 over x squared minus x minus 6. Now, I'm getting ahead of myself a little bit because in the next lesson, I think we're going to be solving equations. We need to know, can the bottom of this fraction ever equal 0? Can it? Well, we need to factor this. So this you should recall from the last time, because there's nothing in front of the x squared. It's an easy one. You can put x and x. Factors of 6, 2 and 3, 6 and 1. What is the thought going through your mind right now? I must find factors of 6 that subtract to give me 1. And they are 3 and 2. 3 and 2. Now, to take 3 times 2 and get a negative 6, you need a positive and a negative. So then you go to the other sign, and that minus sign should go with the bigger one. The inners, 3x, are bigger than the outers. Negative here, positive there. Set each one equals 0. What's going to make this 0 if x equals 3 or negative 2? So what's the domain up here? Can't be 3 or negative 2. So it would be, for this one, all real numbers except 3. Try it. 3 squared is 9 minus 3. 6 minus 6 is 0. All real numbers except 3 or negative 2. How about the last one? square root x plus 1. Okay? You can't take square roots of negatives. So what is going to make that negative? Well, if I put 0 in there, I get a positive. If I put 1 in there, 2 in there, 3 in there, 4 in there, I just add 1, I keep getting positives. If I put negative 1 in there, I get 0. Now think about this. Here's 0. Putting 0 in is fine. If I put negative 1 in, I'm going to get 0, which is still okay. The square root of 0 is 0. But if you go anywhere down here, you're putting in numbers that are big negatively. Like negative 2, negative 3, negative 4 is going to turn that into a negative. In fact, negative 1.1, just to the left of this, is going to make it a negative in there. So what is the domain? Could be this one, negative 1, because starting at 0, there's the domain going in that direction. Okay? So the domain is simply, what can x be? What can x be? Okay? Now let's talk about some operations of rational expressions. How about reducing 5x squared over 20x cubed? Okay? When you reduce fractions, just forget this problem for a second. 10/15. When you reduce fractions, we all know how to reduce this. I just want to show you what's going on behind the scenes. 10 is 5 times 2. 15 is 5 times 3. You can now kill the 5s, right? What did I do in that problem? Okay, I took the 10 and the 15 and I factored them. I factored them into their parts, and then I killed the parts that were the same. I cancel them off and I get 2/3. That's what you can do here. We really don't have, everything is already factored here. It's all broken down to multiplication. 5 over 20 reduces to 1/4. Look at the parts. I can kill 2 x's out of 3. Kill 2 x's. How many are left? 1. Okay? Next one. 5x minus 15 over x squared minus 9. You cannot cancel the one I just showed you before this. You have to break it down into its parts. Everything must be multiplication before you can cancel. You cannot cancel in subtraction. I always get people that want to kill the x's, or they want to take a 3 into both of those. You can't do that. It's connected by subtraction. You've got to do what I showed you first. We've got to break this down. Here we can take a 5 out of the top. Look what's common. Yeah. Down here on the bottom, isn't that difference of 2 squares? You see how factoring is going to help you, huh? I've got it all broken down to multiplication now, and I can kill the x minus 3's. I'm left with 5 over x plus 3. Okay? The rules are factor first. Factor first. Always, always, always. How about a multiply problem? X squared minus 25, x squared minus 16 times x plus 4, x plus 5. Factor first. Difference of 2 squares. X minus 5, x plus 5. Difference of 2 squares. X minus 4, x plus 4. Yeah? Now you have everything factored. You can kill stuff. And you're left with x minus 5, x minus 4. This times 1 is this times 1 is that. All right, factor first. Then you can kill stuff. Okay? What about divide? Hopefully everybody remembers division. Do you remember division from earlier, back in 4th or 5th grade? 3/4 divided by half, all right? 3/4 divided by half. Everybody remember, you change it to multiply and you flip that baby? Yeah? And now, everything's already factored. You can cancel stuff and multiply tops, multiply bottoms, okay? So we're going to do the same thing with this problem down here. It's 2x plus 1 over 2x squared plus x minus 15. Make it multiplication and flip that guy. X plus 3, 6x squared minus x minus 2. Okay? Hopefully you can all see that. All right? Factor first. This is already factored. This is already factored. I need to factor this guy. There's nothing common. It's not the difference of two squares. This is FOIL in reverse, and it's a hard one because there's a number in front of the x squared. So let's talk about what we went through the last time. Factors of 2, 2 and 1. Factors of 15 are 3 and 5, 15 and 1. The thought going through your mind right now should be, I must find combinations that subtract to give me 1. Combinations that subtract to give me 1. Well, you forget the 15, that's not going to work at all. How about 3 times 1 is 3, 5 times 2 is 10. 10 and 3 do not subtract to 1. 3 times 2 is 6. 5 times 1 is 5. 6 and 5 subtract to give you 1. So remember what you do here. 3 times 2 and 5 times 1, circle a pair of them. I don't care which ones you circle. You can either circle 3 and 2 or 5 and 1. I don't care. But circle one of the pairs that works. They go on the outers, 2 and 3. 5 and 1 go on the inners, but they flip. 5 and 1. Put your X's. Whoops. I didn't flip them. Ah, sorry. I said it, but I didn't do it. The 5 and 1 flip. The 5 is here, the 1 is here. Okay, now to get a negative 15. To get a negative 15, one of these has got to be positive and one is negative. So you look at this sign. The plus sign goes with the bigger one. Now be careful here. What is bigger? The outers, 6, or the inners, 5? It's the outers. So the plus sign goes here, the minus sign goes there. Tough. FOIL in reverse, tough stuff. Here's another tough one. There's nothing common. List the factors of 6, 2 and 3, 6 and 1. List the factors of 2, 2 and 1. What is going through your mind? I must find a combination of factors that subtract to give me 1. Subtract to give me 1. So, 2 times 3 is 6. 1 times 2 is 2. 6 and 2 don't subtract to 1. 2 times 2 is 4. 3 times 1 is 3. 4 and 3 work. Circle a pair of them. Either the 2 and a 2 or the 3 and a 1. I don't care. The ones you circle go on the outers. The 3 and the 1, now see if I can do it right this time. The 3 and the 1 go on the inners, but they flip. So the 3 is here, and the 1 is here. Signs. To get a negative 2, one of them has to be positive, one negative. 1 times 2 is 2, but we want negative 2. So you look at this sign. The negative sign goes to the bigger, which is bigger. The outers, which is 4, or the inners, which is 3. The outers are bigger, negative here, positive there. Now, can we cancel? Sure. X plus 3s, 2x plus 1s. This is very ugly, but we just have 1 times 1 on the top. On the bottom, we have 2x minus 5, 3x minus 2. Okay? Everybody with me. Reducing. multiplying, dividing, okay? What else could there be to do? Uh-oh, how about adding and subtracting? Now, we go back to first day of class in pre-calc. Now, I showed you a couple different ways of finding a common denominator. The second method I showed you on that first day is going to be really helpful now. Let's look at the first problem. I have 5 over 3x squared y minus 2 over 2xy squared. Factor your bottoms. They're already factored. They're already all broken down to multiplication. List the first set of factors. 3x squared y. Look over here. I need a 2. Do you have a 2? No. So you've got to take 2 times 3. I need a 2 is 6. I need an x. Do I have an x? Sure, I got a couple of them. I need 2 y's. Do I have 2? No. Put another one there. Now you have your common denominator, okay? Ask yourself the question, what do I do to this to get this? What do I multiply times this to get this? I have to multiply by a 2 and a y. So take the top times 2y, I get 10y. Minus, what do you do to this to get this? I multiply 3 to get that, and I need an x. So multiply the top times 3x minus 6x. Okay? Is there anything you can do to that? You can take a 2 out on the top, factor out a 2, 5y minus 3x, right? And then what you could do is kill 2 into 6 is 3. So you have 5y minus 3x all over 3xy squared, okay? And I just realized now that I'm thinking about this problem, we could have started way up in here and killed those 2's to start with, just reducing the fraction. Would have made it somewhat easier, all right? Next problem. How about 1 over x plus 1 plus 1 over x minus 1. Okay? Factor the bottoms. They're factored. Write down your first set. I need an x plus 1. Look over here. I need an x minus 1. Do I have it? No. I need it. What do you do to this to get this? What's down here that's not there? Isn't it the x minus 1? So multiply the top by x minus 1 and get x minus 1. What do I do to this to get this? What's down here that's not there? X plus 1. So you got to multiply the top. You get x plus 1. 2x. The 1's go away over x plus 1, x minus 1. And don't you dare cancel an x, because down here they're connected by addition and subtraction. That's all you can do. Okay? Last one. All right, here we go. Factor the bottoms. These two are factored. This one is not. This one should be a very easy FOIL in reverse because there's nothing in front of the x squared. So put an x and an x. What are factors of 6 that subtract to give you 1? Factors of 6 that subtract to give you 1. 3 and 2 to get a negative 6. One of them has got to be positive, one negative. So look at this sign. The negative goes with the bigger. The outers are bigger than the inners. Okay, now we're ready to get the common denominator. Write down your first set of factors. What do I do to this to get this? Oops, I missed one. What do I do to this to get this? Nothing. Top stays the same. Minus. What do I do to this to get this? There's an x minus 3 down there that's not there. I need to multiply the top by x minus 3. X minus 3 times a minus 1, there's a negative sign. I'm going to have to be careful and take that negative into both parts. What do you do to this to get this? You multiply by x plus 2 times the top. And I got to take a negative 2 into both parts. Is negative 2x minus 4. And this becomes, when you take this negative sign in, it becomes a negative x and a plus 3, yes? Okay, see if I can fix this up. A negative x and a plus 3. Now, collect your terms. These x's go away. I have a 3 and a negative 4 is negative 2x minus 1 over x plus 2x minus 3. You cannot cancel the 2's. You cannot cancel the x's because they're connected by addition and subtraction. Okay? You got some tougher problems now. Oh boy, look at this one. Here, this is 1 over 1. This is 1 over 1. I need to work on this part, and I need to work on this part first. Okay, so I'm going to work on this part right here first. I'm going to get a common denominator of c minus 1. This is 1 over 1. What do you do to 1 to get c minus 1? You took it times c minus 1. So I must take the top times c minus 1 and get c minus 1. What do I do to c minus 1 to get c minus 1? Nothing. Plus 1. Divided by. Again, this is 1 over 1. I'm going to get a common denominator of c minus 1. What do you do to 1 to get c minus 1? You multiply by c minus 1. So do it on the top. What do you do to c minus 1 to get c minus 1? Nothing. It stays minus 1. So what have I got? Here, these go away. I have c over c minus 1. Division. Change to multiplication. Flip it. C minus 1 goes on the top. C minus 2 on the bottom. These cancel. Don't you dare cancel those c's. Multiply tops. Multiply bottoms. I have c over c minus 2. Okay? Another tough one. I'm going to rewrite the first one. Isn't it 1 over x? Remember negative exponents, you flip it. Plus 1 over y divided by x plus y minus 1. You can't take the power in. We have to flip it. 1 over x plus y. Flip the whole thing. Okay? Now, we have some work to do here. I have to get a common denominator. I need an x. I need a y. What do you do to x to get this? Don't you multiply by y? Y times 1 is y. What do you do to y to get this? Don't you multiply by x? So multiply by x. Divided by. Don't I change to multiply and flip it? And look, oh, they don't cancel. I thought they would cancel. Sorry. They don't cancel. You flip it, and you have an x plus y times a y plus x, or that's just x plus y squared, multiply all over xy. And you cannot cancel anything there. All right? Okay, wrap this up. Now, the last time we were together, we talked about rationalizing denominator, where you would multiply top and bottom by root 3. Okay? But how do you do that one? Multiplying top and bottom by root 5 is not going to get rid of the root 5 on the bottom, because when you multiply by just the root 5, you would have to take the root 5 times that. So that won't get rid of the root on the bottom. But what you can do If you remember difference of two squares and sum and difference factors, how the outers and inners go away, multiply top and bottom by 3 plus root 5. These are sum and difference factors. Your outers and inners should go away, and we'll get rid of the roots. Okay? So, on the top, multiply, I get 6 plus 2 root 5. Okay? On the bottom, we're going to FOIL these guys out. 3 times 3 is 9. Your outers are 3 root 5. Your inners are negative 3 root 5. Don't they go away? 3 root 5 and negative 3 root 5. I'm left with minus root 25, which is 5. 9 minus 5 is 4. Okay? Can I take a 2 out on the top? 3 plus root 5 if you factor out a 2. And now you can cancel. Final answer, 3 plus root 5. All over 2. Rationalizing the bottom. No root any longer on the bottom. A couple extra problems on your homework, okay, with regards to simplifying and factoring. So that should take care of section 4.